All right, in chapter 9, we're going to talk a little bit about solutions, in particular aqueous solutions. This is going to help us for chapter 10 quite a bit. So we'll talk about some properties of solutions. Again, aqueous solubility. This is going to be used more for chapter 10, but I'm going to introduce it to you in this chapter. And then we'll talk about how we deal with solution concentrations. There's a percentage way, like, it's like a 10% concentration of salt in water, something like that. And then another way is by molarity. Molarity is going to be a common unit that we're going to use for the concentration. All right, and then we'll talk about how to prepare solutions. There are a few equations in here that I don't think are too hard. And then just a little bit about colligative properties. All right, so the first thing, what is a solution? All right, a solution is composed of both a solvent and a solute. All right, the solvent, the way that your book defines it, is the substance that is in the largest amount. It's kind of a very weird way, I think, of like all defining a solvent. But it's basically what everything else is all dissolved in, okay? So, like for example, if you have salt water, obviously your water is your solvent and the solute is your salt. All right, that's the thing that's being dissolved in it, okay? Now, the reason that they define it as this is because here's a perfect example. Air is a perfect example. All right, what's the solvent? It's gas. What's the solute? It's gas. Or solution is gas. Yeah, it's basically saying like our solvent is the air around us, and the oxygen is the solute dissolved in it. Okay, it's not like it's not like water or anything like that. But when we're talking chemistry, we usually have something that is ionized or dissolved in a solvent, in a liquid. All right, so we're going to be using this term a lot, an aqueous solution or aqueous. This implies that water is our solvent, okay? Just because it's so common. So if I say I've got sodium chloride, I'll say that it's aqueous. It's in the aqueous state, okay? So we're going to be using that term quite a bit. So I'm sorry. So just to go back here, we're going to be using these terms a lot. A solution, we're going to be using solution. And when I say the word solution, that includes the solvent and the solute. Okay, remember, the solute is the thing that is dissolved in the solvent. All right, there's different ways that we can describe a solution. All right, it's either a saturated solution, an unsaturated solution, or a supersaturated solution. These terms people pretty much know, especially the difference between a saturated and unsaturated. Saturated just means it's the maximum amount of solute that you have dissolved in your solvent. In this case, we're talking water. Okay, so if you take salt, for example, and you put it into water, all right, and you stir it up and it dissolves, and you put more salt and it dissolves, and you put more salt and it dissolves, okay? This is considered an unsaturated solution, is when you have less than a saturated amount. It keeps like dissolving. But then you're going to get to a certain point where they kind of show you down here that you're going to put so much in there that eventually it does not dissolve anymore. Okay, well, inside of the solvent, you have the maximum amount of salt that's all dissolved. It won't allow any more salt to actually dissolve in there. Okay, so that's what's implied by a saturated solution. When you have the maximum amount of solid, even if when you put more solid in there, it won't do anything. It won't dissolve anymore. Okay, unsaturated obviously is anything less than that. Supersaturated is when it has more than our saturated amount. You might be saying, well, how is that possible? How can you dissolve more if it doesn't like dissolve anymore? Usually you have to heat it up. Okay, so what you do is you reach a saturated point right here. Saturated, that should be ED. All right, and you take this and you heat it up and it all dissolves in hot water. So this would be hot. all right, it all dissolves. And then as it starts cooling down, the excess will start recrystallizing out of this. Okay, I think they show it in the next page. There you go. So this is where you have a saturated amount and you heat this up. Okay, and then as it cools down, or if you put a crystal in there, they're kind of showing you how they are putting a crystal in there, the excess just starts crystallizing out. I think it's kind of a cool picture to kind of show that. All right, if you've ever made rock candy before, I don't know if you've ever made rock candy, but you're basically making a supersaturated solution. What you're doing is you are putting in tons and tons of sugar into water and you're boiling it. And you wait until it all dissolves, and then you take it off the heat and you put either a string or a stick inside of the water and you keep it in there until it cools down. And as it cools down, the excess sugar starts crystallizing in these little nice crystals on top of the string or the stick. And that's basically what is happening here in a supersaturated solution. All right. 9.2, so that's basically all the terms you really have to know for 9.1. 9.2 is a solubility chart. This is a different chart than what's in your book. I like this chart better. You will also be given this chart to you on exam, so you don't have to worry about it. And basically, there's lots of salts that are soluble in water. And what we mean is, in this term of soluble, is it ionizes. This is the important term, it ionizes. What does that mean? If I take sodium chloride, again, which is salt, it's a solid, okay, and I throw it into water, and it, quote unquote, it dissolves, okay? It's not really dissolving. What it's doing is it's actually ionizing, okay? Obviously, you can't see it anymore. You put it in there, you swirl up, and it's gone, right? It's not gone, obviously. What it does is it ionizes, is that the white salt breaks down into individual ions, right? And we know, each ion is so incredibly small that you can't actually see it, okay? So like salt, we are talking 10 to the 23rd atoms all bundled all together. But as soon as you throw it into water, each of them are now independent on their own. They're not in clusters anymore. Okay, so that's what's happening. When you take salt and throw it into water, it ionizes into its individual ions, and you get water that is in between all of the atoms. Okay, so that's why it looks like it dissolves, but in reality, it's ionizing. When you take sugar and throw it into water, that is what we call it dissolves, because it doesn't ionize. Sugar is not an ionic compound. All right, and I believe we talk more about this in chapter 10. Okay, but this is kind of a solubility chart. This is a pretty good chart. Probably 90 to 95% of the molecules that you see as that are common common elements are pretty much on this list. All right, and this basically, I'm going to kind of show you kind of this line right here. All right, anything that has these ions in it is usually soluble. Okay, anything that has a lithium, a sodium, a potassium, or an ammonium ion is always soluble, or it ionizes. So I have like lithium, like sulfate. If I take lithium sulfate and throw that into water, it will ionize. There are some ionic compounds that are not soluble in water, or they do not ionize in water. Once these ions come together, they actually are so strongly bound that water can't go in between them and ionize them. Okay, and that's kind of what these are right here on the exception list. Okay, so pretty much anything with these ions, all right, and notice the lithium and sodium and potassium are the group 1A, group 1A. Okay, so if you look at on the periodic table, on the first group, you'll see lithium and sodium and potassium. Obviously not ammonium. Ammonium is not a metal. All right, acetate, nitrates, those are also completely soluble. So if you have like lead nitrate, lead has a 2+ charge typically. All right, if you have lead nitrate, that will completely ionize in water. It's completely soluble. All right. Most halides are soluble with the exception of silver and lead. We're going to ignore all the mercury ones. We don't really talk about mercury. Mercury can do some strange things. So we are not going to talk about mercury in our class. But notice, silver chloride, lead chloride, silver bromide, lead bromide. silver iodide, lead iodide. So notice silver and lead are completely insoluble. These are exceptions. So if I have lead chloride and I throw it into water, the solid just falls down to the bottom of the solution. It does not ionize. These are exceptions. But other than that, every other, like if I had iron 3 chloride, that would be completely soluble. Okay, so that's kind of how you read this chart. With sulfates, all sulfates are soluble, with the exception, again, of silver and lead. Again, ignore the mercury. But this time, we're also going to include calcium, strontium, barium, which is the group 2A. Group 2As. So pretty much with sulfates, every sulfate is soluble with the exception of these 5. Okay, other than that, it's completely soluble. So if I have like um, magnesium sulfate, that would be soluble. Okay, if I have iron sulfate, that would be soluble. It completely ionize. Okay, now down here, this half of the chart is the complete opposite. All of these are completely insoluble. Insoluble. So any type of carbonate, iron carbonate, magnesium carbonate, strontium carbonate, whatever carbonate you have is completely insoluble with these 4 exceptions. There's only 4 exceptions, and it's based off of this rule up here. Because we said anything with a lithium, sodium, potassium, or ammonium is always soluble. So that rule is being shown here. Actually, it's being shown completely all down here for all of them. But pretty much every carbonate, magnesium carbonate, strontium carbonate, iron carbonate, manganese carbonate, whatever carbonate you have, it will not dissolve in water unless it's lithium carbonate, sodium carbonate, potassium carbonate, or ammonium carbonate. Those are the only carbonates that are soluble. These are soluble in water. Same for phosphates, same for sulfides. If it's a lithium, sodium, potassium, ammonium sulfide or phosphate, they are soluble. Otherwise, they're completely insoluble. Hydroxides, same thing, the group 1As, but this time we're also going to include the 2As. Okay, so these 1, 2, 3, 6 hydroxides are completely soluble. Okay, so hopefully that makes sense. There's a lot of writing on here, but hopefully that makes sense as far as the solubility. We are going to see this again in chapter 10 quite a bit. We're going to be doing these reactions called precipitation reactions, and we're going to be using this chart to kind of help us out with that. All right, we're going to stop there for the video for sections 9.1 and 9.2.